Good morning, everyone. Thank you for coming to this session. We're going to be talking about the future of analytics. A quick summary: the last decade of analytics best practice is rapidly becoming obsolete and being replaced by technology that's faster, simpler, easier to use. As I go through this, let me just put a quick plug for Twitter. If you're not on Twitter, you're missing half the fun of today's conferences. So let me just see, let's just go see what's going on in the world. So you put in the hashtag, whoops, and press enter. With a bit of luck, we'll get the live feed of all of the tweets about this event right now. And this is using SAP dashboarding technology, incidentally. But just you get the inside track. You can actually get the audience talking to each other, as Ray mentioned yesterday. It's a bit like passing notes around in class. You get to hear what other people think about what the presenter is saying. So even if you're not registered on Twitter, you can go and actually find out what other people are saying. It's a fascinating thing to do. I'm a huge fan of The Economist. I'm an econometrician by training. Here's a good summary of what's happening to the economy right now. Stand back, I'm a central banker. People are trying to revive the dead corpses of countries like Italy and Greece and improve where we're going on. Another cover from The Economist. Is it time for a double dip? Is it safe to go back in the water? They think there's a danger of another recession. Why do they think this? Well, analytics, of course. They have something called the R-word index, where they monitor the use of the word recession in articles. And they found that that's a leading indicator. Normally, economists can't tell you're in recession until several months after it happens. But because it's based on expectations, it may well be that we're already entering into a new, smaller recession after the last one of a few years ago. Big other trends. I found this the other day. If you have an iPad, you are holding a supercomputer in your hand. If you cast your memory back to 1994, not that long ago, the iPad 2 would have been on the top 10 list of the world's fastest supercomputers in 1994. If you remember the Cray 2, the super cool thing the size of a jacuzzi, so the iPad 2 is actually faster than the 4-processor version of that machine. It's amazing how far technology has come. I won't bore you with how much information there is in the world. I thought this was a great representation of it. This is an artist, Eric Kessel. It's a show in Amsterdam right now. And he printed out every single photo that was uploaded to Flickr in a 24-hour period. So that boy is literally drowning in at least one form of information. Ultimately, I'm a huge, passionate believer in analytics. Whatever you're trying to do in your organization to improve any part of the business, I fundamentally believe that you have to start asking questions before you can do anything else. Whether it's improving your financial performance, sales, brand loyalty, every aspect of your business is intimately tied up to better analytics. All the surveys agree with me. Business people believe that data is extremely important for competitive advantage, makes an important contribution to customer relations, help manage costs, or improve operations. And perhaps because of that, there's been huge growth in business analytics. In 2009, it was a 3.8% growth in the market. Anybody care to guess what it was in 2010, the most recent figures we have available? 10%. Any raise on 10? Going once. That was actually 13.4%, over triple the growth, according to Gartner. And one of the reasons for this is a bigger and bigger proportion of IT budgets is going to analytics. To be simplistic, we're spending less money on ERP and more of that money on getting the value out of the ERP systems we already have. And this is actually part of a bigger, more general trend in IT spending. It's moving away from efficiency, and it's moving towards effectiveness. So rather than the IT budget something to be minimized, it's now being used increasingly to empower business people to do things better. So analytics spending, collaboration spending, spending per head is supposed to rise by 60% by 2015. So we're really seeing a sea change in how IT is being used to change the way the company does business. Here's the figures of analytics around the world. Here in Western Europe, we're doing okay. 6.7% growth, very reasonable. And you can see that the growing economies, Asia, Latin America, Middle East and Africa, are growing strongly off smaller basis. But the interesting figure is North America. So it's by far the largest analytics market, and it grew at 17.8%. So it is interesting that the people who are using this most are really doubling down and using even more of it. I think there's some lessons we can take from that here in Europe. Of course, happy to show you the market shares. SAP has almost 50% more share than our nearest competitors. And what's interesting is that there has been an ongoing trend of consolidation in this industry. I was originally with Business Objects, and it's clear now that business intelligence is starting to become part of the bigger applications market, starting to blur with other things. There were some very small BI vendors that did very well, but they're pretty much taking market share off each other. The top 4 mega vendors increased their market share and have done for the last 5 years running. So, a quick summary of what we mean by analytics. So we help get data from lots of different data sources, structured and unstructured. Then we help you store that, data warehousing, help you cleanse it, integrate it from multiple data sources. Information on its own is useless. You have to expose it to people, let people do reporting, dashboarding, analysis. We actually provide a whole set of packaged analytic applications now, aligned with particular line of business areas. And enterprise performance management. You have to take the data and actually change something in the way you do business. That often passes through the finance function. So we have some fantastic financial planning, budgeting, profitability tools. And last, but by no means least, we have governance, risk, and compliance products. We strongly believe that you shouldn't be looking at your key performance indicators without looking at your key risk indicators at the same time. Obviously, once you have all that, we need to be able to provide it through lots of different devices, increasingly mobile, and provide you the services and best practices to make the best use of all that technology. This is from 1940. So this is an ad, and it's talking about the office of tomorrow. And I thought this was perfect. Intricate calculations of quotas or sales by territory will be turned out at the touch of an assistant's finger. Records will appear as if by magic from files. So this sounds an awful lot like the analytics we have now, 60 years later. And what I find fascinating about this ad is that, so it just shows that the business need for analytics really hasn't changed that much over the last half century. What I love about this ad is it's actually an ad for Canadian whiskey. So back when decision-making and drinking alcohol went hand in hand. If you've ever seen an episode of Mad Men, I think they'd appreciate it. So here's another fun thing I stumbled across. Google has a great thing called Ngram that allows you to search through words in all of the books that have been ever published throughout history. So this is the chart of data versus information versus knowledge versus wisdom since the 1800s. So you can actually see that data and information has risen massively. These are the mentions in books, while knowledge and wisdom have been pretty flat. So clearly, we have a problem here. Information and data going up, knowledge and wisdom, yeah, not so much. And here's really the problem. It's not that analytics isn't better than it was 20 years ago. It absolutely is. But if you ask business people how satisfied they are with business analytics, they tend to come back being just as dissatisfied as they were 20 years ago. So, does this mean everything we've been doing is useless? No, it means that while we've been working hard to improve analytics, people's expectations have been rising even faster. It's a little bit like trying to walk up the down escalator. So you have to scramble just to keep up with people's expectations, especially being exposed to technology in the consumer world. So we actually want to do analytics better. We have to make a big leap forward. We have to change something in a fairly radical way in order to make a difference. And that's what the rest of this presentation is all about. So a typical presentation today looks a bit like this. We get information from our various information systems. We tried to do analytics directly off our data. It didn't really work because we slowed down our systems too much, so we created operational data stores, a copy of the information. We realized that we needed to integrate information from multiple sources and store the history, so we created data warehousing. We quickly realized that by the time we stored that data, it was really hard to get it out unless we had optimized the data warehouse environment. So lots of indexing, lots of pre-aggregated tables. And even with that, there was a lot of data that was just too much hassle to get into the data warehouse. So we had lots of data marts on the side, either from the original systems or from the data warehouse. So that's data warehousing today. That's pretty much best practice. The only problem with it is it's slow, painful, and expensive. It works, but surely there's a better way. If you're a business person in the audience and you've ever wondered why it seems so hard to get any data out of your company's computer systems, well, this is really the answer. The data has to go through all of these different levels before you can actually make any decisions based on it. It's like an onion. The more layers you have, the more you cry. So what's the problem? Today's databases basically weren't designed for analytics. Relational database technology goes back to Ted Codd, first published a paper around 1970. I'm very proud. He went to the same grammar school as I did in Poole. But it just really wasn't designed for analytics originally. So what's changed? There's a real revolution going on. And this is not just me, not just a marketing term. So Gartner says that data warehousing reaching its most significant inflection point since its inception. Analysts like Credit Suisse, we believe the industry stands at the cusp of the most significant revolution in database and application architectures in the past 20 years. Now, so revolutions are exciting, but they're also a real pain because it means we have to rethink everything that we've gotten used to. We have to learn a lot about the new world. So what's the big problem? Well, disks really can't keep up with the processing power of today's chips. It can be 1,000,000 times faster to access information from live memory than it is to go and search it from a disk. And the real thing that changed is the price of memory has plummeted. The very first computers were in-memory computers. That's all there was. There was no such thing as a hard disk when they first started. The difference is live memory was always too expensive to use, so we had only small caches. The cost of 1 megabyte of memory in 2000 was around £1, and if we equate that to the tallest tower in Birmingham, anybody tell me the tallest tower in Birmingham? I know you all have hangovers. Okay, from the front, yes, Alan, very good. Post Office Tower, BT Tower, excellent. How tall is it? Very tall, yes. Okay, so it's 152 meters tall. So we'll make that the cost of memory in the year 2000. So anybody care to guess what the cost of, what the equivalent height is now? I'll give you a hint. It's less. A matchbox, says Donald McCormick in the front row. Nobody ever wants to say. So it's about half a halfpenny now, halfpence. So it's actually roughly the size of my 7-year-old daughter. And unlike my 7-year-old daughter, it's actually shrinking. The price performance of memory has more than doubled in the last 9 months. So it's getting much, much cheaper to use memory within your computer systems. So what can in-memory computing do for us? Well, the advantage is it's thousands of times faster to do calculations in memory, do analytics in memory than it is to get it off disk. This means we don't have to do all of the different optimizations. We don't need the data marts anymore. That woke people up. We don't need the aggregates anymore. We don't need the indexes anymore. So we can already speed up our data warehouses using these technologies, as SAP started to do already a few years ago with BW Accelerator. But it's not the only technology that counts. There's also this notion of column stores. What's a column store? Well, here's one way to explain it. This is my filing system at home, and sad to say, this is actually my filing system. Whenever I get something in the post, whether it's my pay slip or a tax bill or a telephone bill, it all goes into one huge pile of paper. And it's incredibly efficient to write to my database. right? So I just open the envelope and put it on the pile. I'm done. But when it comes to analytics, it's not quite so easy. When I do my tax returns, then I have to go through the whole database, a full table scan, to get just the pieces of information I need in order to do my taxes. And as ridiculous as it sounds, that's pretty much how modern relational databases work. They're optimized for writing because they were optimized for ERP operational activities. My wife is much smarter than me, and she uses a column-based system. So she does some upfront work. When she gets something in the post, she'll sort out the data, and she puts the phone bills with the phone bills, salary slips with the salary slips, and so on and so on. But when she goes to do a query, and she wants to find all of the phone bills, she can do it hundreds or thousands times faster than me because she just goes to that one store of data. That's pretty much how a column store works. So another way of putting it is that everybody plays Tetris. So row-based database, this is an exaggeration, but row-based database, you get lots of sparsity. You're storing data row by row, and you're storing essentially empty cells if that column isn't filled. With column data stores, you're doing some upfront work, like Tetris. You're switching the data around, and you're storing it in the form of columns. There are two advantages, really. One is that it compresses naturally, so there isn't any sparsity. You don't store empty values. And the other advantage is the compression algorithms that we use in modern technology work much better. If I store all of my pay slips together, I get paid the same amount each month, so I just store it once and say times 12. So that means we can compress the data even more on top of the original level of compression. So what does this mean for our diagram here? Well, it means that, again, we can do querying up to thousands times faster. The typical aggregate query that we do in analytics will be much more efficient using these new databases. Sybase IQ was the pioneer of this technology. It's been around for a good few years. And we can minimize the size of the data warehouse, so it's less sparsity and better compression. More data in less space, which in turn means that you can actually get it out faster. So there's yet another speed increase because of that. We're then going to use massively parallel hardware. It turns out that the column stores are optimized for massively parallel architectures. So if we go back to my stack of paper, imagine that my wife and I stored all of our documents in the same stack of paper. If we both tried to do our taxes the same way, we'd get in each other's way. Right? I'd be trying to get some paper, she'd be trying to get some paper, we'd slow each other down. That's pretty much what happens with relational databases. Both processes are trying to access the same rows. With the column store, she can have her folder, I can have my folder, we don't get in each other's ways. It turns out the column stores are much better adapted for massive parallelization than traditional relational databases. So again, we can go much faster. We're going to use dedicated hardware instead of a generic machine. And we're going to push the BI engine in there as well to simplify the engine. So this is just an example of a company that's been doing this. This is the very first company to Red Bull, who are they're part of the ramp-up of BW on HANA. So they have been switching their BW environment from BWA, the BW accelerator they've already been using, to BW on HANA. And they saw a lot of compression, down to 80% data compression, 1.5 terabytes down to 200 to 300 gig, and much faster data load, because it's all loading directly into memory, not too much slower disk. And the big advantage is this notion of, this is from their own customer deck. They presented at Sapphire last week. You can actually watch the video if you go to the Virtual Sapphire site. And they basically get rid of an entire layer of their infrastructure. So simplifying it, BW does a lot of the things directly into disk without having to actually create manually the tables. Next big thing we're going to do is going to push a lot of the processing into the database itself. So this is an example of what happens if you're trying to do some planning today. I change one value, but now that has to be put into all of the 52 weeks, 500 different branches, and I have to take that value and pass it out to my database. So that means 26,000 different database writes, each one slowly onto disk. The new way we're going to do it is we're just going to write to the database once and let the database do all of the work itself. So I'll push it down, And then the database has the technology itself to do the planning, to take that value and say, okay, now I'm going to put it across those 52 weeks and across those 500 values. So much, much faster use of typical analytic processing using these new technologies. So really, you could say that HANA is the first database really designed for business, where lots of the kind of calculations that we do in analytics are actually done within the database itself, instead of doing it at the application layer. It's just much more efficient way to do it, using the full power of these massively parallel architectures. You can also do things like predictive analytics. Today, we have to take a subset of the data to a separate environment, do our predictive analytics, and then use the model for other things. We can actually start doing that directly within the database, doing forecasting, trends, and so on, directly on the data sets as a native function of the database itself, not just SQL, aggregates. So, up to 1,000 times faster, again, using these in-database analytics, we can actually push the calculation engine down into the analytic appliance or the analytic platform itself and further simplify the architecture. Next, the flows of data. So it's going to a more continuous flow of data. We're used to batch processing of information into our analytic systems. Well, let's do it more of a flow, more of a waterfall than an iceberg. So we're going to replicate, anytime we have a new value in our operational system, we're going to replicate it and put it into our analytics system. So we're actually going to move away from sort of ETL, extraction, transformation, loading, and start doing more ELT. So extraction and loading, and then the transformation part we can actually push into the database itself using some of these powerful calculations. Remember, it's in memory, massively parallel. It's without a doubt the fastest place to do everything, so we can do it on the fly using the Delta data sets that come in for our solution. Or, just as an aside, we have a product, Event Insight. It does a complex event processing, and this is where you have data that never goes anywhere near a data warehouse. You're just detecting events on your operational system, and when you see a combination of different events, you can trigger alert directly to an Excelsius dashboard without having to go anywhere near a dashboard in the first place. So we're going to get data in more or less real time. So every time there's a new data field in the system, we're going to replicate it to the analytics system. So we don't really need an operational data store anymore. That was just a copy of the data. So we've just got rid of another layer, we've simplified it, and we're now really going back to what we started with, trying to do querying directly off our operational systems. So the big advantage of all this is the idea is it gives you the elephant and the cheetah. You get the massive amounts of data, but very fast performance. This is one customer example, a bank we worked with. On average, they took exactly the same data, the same schemas, moved it into in-memory HANA, and saw, on average, a query speed up of around 369 times. And there are customers who have seen much more than that, others have seen less. But the key is, so 369 times, that's just a number, it doesn't really mean anything. But imagine you're a world-class marathon runner. 369 times faster means you could suddenly run a marathon in 33 seconds. I think that would give you a competitive advantage. And it's not just about analytics. One of the key things about these in-memory technologies is it really wasn't designed for analytics originally. It was designed for applications. So if we take this in-memory appliance and make it ACID compliant, so atomicity, consistency, integrity, and durability. These are 4 things you need to have a production-level database. If you add that, you can actually get rid of this notion of analytic compliance and run your ERP system in memory off these kinds of environments. So every new line that's being written is just being written directly into memory. You don't ever replace a line, you only do updates. And this is where people start going, whoa, that sounds a bit radical. I was okay up until then, but nah, I'm not sure about that. So this is going to take a little while longer, but it actually absolutely is where we're going with the future. If you look at today's applications, this is a typical finance application. So you have the base tables that store your records. And then we have hundreds and hundreds of aggregate tables for all of the things we need to do on that data. So today's applications, if you actually look at what all of that code is doing, is basically materializing caches upon caches upon caches to avoid the problems of database access, to make sure that when you're asking for new data, it caches it as much as possible. So the future, though, is to get rid of all this, and the future of the financial applications will look a bit more like that. You basically have the two tables, you just store the data you need, and everything else is being done on the fly using the power of HANA. You only store it once. You massively simplify everything you're doing in the underlying application. Everybody's looking a bit scared and nervous now. The key is this is not about, we talk a lot about in-memory, but it's not really in-memory on its own. In-memory is a fantastic technology, but it's only when you combine all these technologies together that you really get the benefit, or really the beauty of the technology. So in-memory, the reason it wasn't used, it was too expensive. It's become cheaper. But when you associate it with column data stores, it gets even cheaper because you can compress the data with the column store. So suddenly, in-memory is 4 to 10 times better price performance than it was if you're not using column store. The problem with the column store was that it was relatively slow to get data into the column store. But if you're doing it in memory, it's suddenly thousands of times faster. You don't care about that extra overhead. Massively parallel architectures, again, column stores are optimized for these kinds of architectures, and the same with the calculation engines. They naturally break down every calculation and push it off to the different nodes. So there's this lovely virtuous circle of all of these technologies coming together that's creating this tipping point, and this is why there's so much excitement in this space. So everybody pretty much agrees traditional disks are dead. 70% of Global 1000 organizations will load detailed data into memory as the primary method to optimize BI application performance. And once we've got that fundamental architecture, we can extend it. BI on demand. Why should you have to buy yet another machine? We're actually offering SAP HANA-powered BI on demand as part of our bi.ondemand.com platform. So you can have cloud computing, access to this kind of power. You can load our unstructured and personal data. One of the big problems we can't load data today into our systems is it's just too complicated. We can't ask end users to load data into BW through all of the different aggregate tables and all of that complex metadata. But if you can just let people upload their own raw level tables, we can do that. I'll talk about that in a second. And of course, we want to extend it, make it available on mobile devices, and help people collaborate around information. Anyone know who this is? We'd have to take a really keen Formula One fan. So it's actually Mario Andretti. If things seem under control, you're just not going fast enough. So I think that really does apply to modern business, right? So we talked a lot about speed, and the one thing that everybody knows about HANA is that it's fast. But it's fast is really not actually the point. It certainly is fast, but the real difference is it rethinks the way we do things. Does everyone remember this? When was the last time you took a picture on film? Is anybody still taking a picture on film? Is there any arty type doing their own darkroom on black and white? There's usually one or two people. So remember film? So you buy the film, it's quite expensive. You load it into the camera. You had to know what kind of film you needed in advance, whether it was tungsten film or daylight film. And then you take a picture, and then you'd have to hand it off to some experts. And after 3 days, they'd give you the pictures back, and it would never be quite what you wanted. You accidentally sliced off Aunt Jemima's head, And that sounds a lot like analytics today, doesn't it? Hand it off to experts, and when I get it back, it's not quite what we wanted. So the difference is digital photography came along. And yes, it was faster, but the real difference is it just changed the way we interacted with the photography process. We take a picture, we had an instant feedback, we don't need experts anymore. And above all, we've become better photographers because we can do it iteratively. Because we have that fast feedback, we take the picture, it's not what I wanted, I can delete it, and start again. And this is really the big difference between these newer in-memory technologies and the old-style data warehousing. Yes, they're faster, but the bigger difference is we're all going to get better at analytics because of this. And a lot of the arguments that people put forward against these kinds of architectures, there's fewer and fewer people arguing against them, but they tend to sound exactly like the kinds of arguments that photography purists used to use against the early digital cameras. They don't have enough pixels, I can't look through the viewfinder. They were valid criticisms, but let's face it, the technology evolved so much faster than the alternatives that, you really don't want to be Kodak. Poor Kodak is now, their stock is at sort of 0.5 cent or something because they couldn't make the turn to the new technologies. So you're doing analytics on film today. We need to get you to digital cameras, and we need to help you through that transition as smoothly as possible. So it's all about flexibility. This is, everybody knows who this is? Charles Darwin. And this is the only picture you will ever see of Charles Darwin sort of smiling. I had to use Photoshop. And why wasn't he smiling? Was he a grumpy guy? Well, no, he went back to photography. Remember, he had to stay still for 5 minutes in order to get an in-focus picture. So it's not the strongest that survived, nor the most intelligent, but the ones most responsive to change. And I think this is true of modern business. It's not that we don't know how to do analytics. We absolutely do. We have 2 decades of best practice. The problem is we don't have time to do analytics well. Business people come to us and say, well, we have this project, we need this data, and we say, well, in 6 months to a year, we can get around to doing that. In the meantime, they say, yeah, thanks, but no thanks, and go off and either guess or try and use Excel or sign up for some other vendor that isn't controlled by a central IT. They have the budget themselves. So it's creating a lot of these silos throughout the organization. The advantage of these technologies is that we can start bringing that back together and doing analytics fast enough to respond to the business needs. And I've made it sound like we're all going to have this one machine that everything's going to run on, and we're going to have this beautiful, clean architecture. But let's face it, we're never going to see that. There's always new information coming online, different time horizons, different levels of analytic needs. It's always going to be messy. The difference is, with these new technologies, we can just react faster, so that when a new data is available, we can jump on that problem faster and react faster, even if we don't have this unique machine that will try and do everything that anybody ever wants. Just as an example, this is a view of the HANA modeler. So if any of you are used to business objects universes, for example, so this is just a metadata view of a data warehouse. It's the same in BW. The difference is these are not real tables. This is just metadata. So if I want to change this data warehouse, if I wanted to add a new table here or change a table, in the old world, that would actually physically mean dumping and reloading tables from the raw data sets. Now, it's just metadata. I make the change, and it's instantly available. It's the notion of universe, if you like, is being pushed down into the data warehouse level. What about flash disks? I've had lots of people come back and say, well, yes, in memory, I don't know, sounds a bit radical, but I'm just going to replace my slow drives with flash disks, solid-state disks. How about that? And the answer is yes, that's cost-effective. It's probably a good thing to do, but it's certainly not a revolution. It's 2 orders of difference in terms of speed. You don't get all of the advantages that we've been talking about. It's an incremental step. It's maybe Polaroid film or something, where you're getting, it's better than the previous technology, but it certainly isn't a step towards the new world. Hadoop, NoSQL, big data. This is an entire presentation on its own, but you probably heard those terms. These are people using open source algorithms to crunch numbers. The big web companies are doing this, and it's actually proven its value, and it's been a bit separate from enterprise data warehousing. Just to summarize, clearly Hadoop is very good for pre-processing messy data sets. It's sort of advanced web ETL that then typically the people put into enterprise data warehousing. But in the future, clearly these technologies are coming together, and we're already doing that. The next version of Sybase IQ, for example, includes links to the Hadoop technology, so you can start leveraging that technology within your organization. And we'll be publishing more information about HANA and Sybase IQ and Hadoop and so on very shortly. We tried to make the transition as easy as possible, so we're putting this HANA technology into applications for particular business needs. There's a whole slew of them coming out. Whatever your business area, there's undoubtedly one of these solutions that's available for you. Here's some of the big ones. So RDS, operational reporting, offloading a lot of the operational reporting from your SAP systems, using HANA as an acceleration mechanism. The COPA accelerator, so doing your profitability to a much more powerful level. And again, it's fairly easy to input these technologies because you're using the same application logic, and we just push more of it down into the database itself. Dynamic cash management, helping you make sure in real time the visibility of your company's cash position with a lot of analytics built into the application. So rather than assuming that your customers are going to be paying when their contract says they're going to be paying, we actually do it on the history of their payment terms, which is far more likely to be accurate. We can start doing forecasting and trending of the future based on the dates we have in our systems. If you actually want to try this out, you can go to, there's the experiencesaphana.com website, and you can actually go there and sign up and trial some of the technology. Some of it is like an advanced demo of the COPA accelerator using Business Objects Explorer here, but you can actually sign up if you're a developer for a sandbox version of HANA. If you're a partner or if you really just want to get to grips with the technology, you can go and start playing with a HANA modeler yourself up on the site. And we will be extending that website more and more going forward. There's not as much as we'd like yet. You can take all of the great data in the world, but if it's not got the right quality, then there's no point in faster analytics. Here's some favorite examples. It turns out that the world exports 331 billion euros more than it imports. So it turns out we're sending a lot of handbags off to outer space or something. Just because of the calculations of each country, and you add them all up, they don't add up. Germany had a bit of an oops. Don't you hate this when you just overlook 55.5 billion euros? They set up a bad bank, and a spreadsheet error, unbelievably, $55.5 billion went missing for a few weeks, making big differences to what they thought their debt exposure was for the German economy. Ireland did something similar to a lesser extent, a housing fund, another 3.6 billion euro oops. This is one of my favorite ones. This is Sweden. A couple of years ago, and the statistics agency accidentally miscalculated the rising cost of shoes. So this is the agency that's responsible for the inflation index for the country, and they accidentally put the rising cost of shoes at 24% over the year. Right? Again, probably a spreadsheet error somewhere. It was a bad calculation. But that turned out, so the direct cost was, that meant that they paid out 700 million kroner extra to social fund recipients, so, welfare people, so it was indexed. So they paid 84 million euros more than they should have done. And it actually had indirect consequences because the central bank looked at the inflation figures and said, whoa, okay, inflation's really high. We have to raise interest rates. And so that actually cost the government billions in extra lending costs because of a spreadsheet error. Ouch. And closer to home, this is the company TalkTalk. They had to pay Ofcom £3 million in fines for sending out 62,000 erroneous bills asking people to pay for services they hadn't received. So there's lots and lots of bad data out there. Data quality is a real problem. That is actually deliberate. Somebody came up to me, bless his soul, after a presentation and said, oh, you do know that you spelled data quality wrong? So 88% of us see data as a strategic asset, yet. 33% have lost a customer, a new business deal, as a result of missing data. 30% have lost business due to mishandling of data. 30% of operating revenue is wasted through process failure and information rework. So that's a huge number. Only 4% of companies rate their data quality as excellent, and 63% have no idea how much data quality might be costing. 17% have no plans to start a data quality initiative. So everybody agrees that, hands up if you have a data quality problem in your organization. If you don't have your hand up, you're in denial. We all have data quality problems. The problem has been it's very intractable problems. It's not an IT problem, it's not a business problem. It's some combination of the two. And there's been some great steps forward in this area around information governance. We have a fantastic product called Information Steward that allows business people and IT people to first find out where they have the data quality problems and then collaborate around fixing it. And that includes pushing off some of the data cleansing to the people that actually understand those data sets the best. So you have these sort of data cleansing package builder where business people can create packages of information, and that becomes an integral part of the data quality aspect. So I honestly believe that this is one of the biggest areas where you can get bang for your buck in your BI and analytics, is investing in these kinds of solutions to fix your data quality. Same for financial information management. So we've taken our ETL technology, data services, and wrapped it specifically around the kinds of processes that financial people need to take information from different systems and make sure that the right accounts are lined up and so on. If you're interested in information governance, there's a great, lots more information from Sapphire again. There was customers like Vodafone, Leander and others were on stage discussing why data quality was important to them and how they'd managed to fix it from both the IT and business point of view. Even things like data, how does data quality come in with things like HANA? Well, we can start doing more real-time data quality. We can actually push the data quality algorithms into HANA itself. They become another processes. The fuzzy matching we can start doing directly within the database. As we get new data from our operational system, we can scrub it and cleanse it on the fly. Social data, so let's see if anybody's been tweeting. Let's see if anybody's out there. All right, if you tweet something in the next 30 seconds, it might come up on the screen. Okay, this is where I find that the screen is full of insults about my presentation. No, okay, it's good. So this is social data. So this is, how do we integrate unstructured data into our systems? Well, we can show it as part of a dashboard. That's kind of fun. But what we'd really like to do is get the value of this information. So what we'd like to do is really just start doing things like sentiment analysis. So if I say, I love Birmingham in the winter, and what I'm going to do is I'm going to send that off now to text analysis in the cloud. And it comes back pretty much instantly and tells me that Birmingham is a city and that love is a strong, positive sentiment. Just to show this is work, if I say, I hate Courtney Love. Let's do the singer. I hate the singer Courtney Love. I'm sorry if there are any Courtney Love fans in the audience. And I'll send that off. And it knows, in this case, that Courtney is a first name, Love is a last name, and the whole thing is a person. Singer is a type of person, so it identifies different aspects of the phrase. And, of course, hate is a strong negative sentiment. So we can do this for Twitter, for example. There's an example of that on experience.sap.com. But it can be any kind of information, insurance data, hospital records, anytime you have structured and unstructured. And again, it ties back to the technology. It turns out that column stores are extremely good for storing indexed text information. And it turns out that the text algorithms that we're using, we can also start pushing into HANA as one of those in-database analytics. So again, it's all about this new architecture and leveraging all of these technologies coming together. Medtronic is a company that have been using this. They've started using HANA. They store a lot of information about customer complaints. They do things like defibrillators, medical electronic devices. And they've been using HANA to do analytics on top of all their structured data, but they also have a custom interface they've put together to analyze all of the unstructured information. So I apologize, the screenshot is not a great resolution, but again, they presented at Sapphire last week. You can watch the video of them presenting their project. They can drill down into a particular complaint, do analytics on how complaints have changed over time for particular ranges and types of product. And you can go to experience.sap.com to see examples of the technology being used on Twitter. And my screen is... Ooh, that's not a good sign. I managed to crash PowerPoint. No, there we go. End user enablement, so that you can use these new technologies to actually take people's personal data and say, rather than you having to use Excel or some other BI product, we'll let you upload it to the data warehouse. Not the main data warehouse itself, but there's a sandbox as part of the HANA backbone. So a brand new product called Information Composer. This is part of the next version of HANA coming out, where I, as an end user, can grab a data set, Excel spreadsheet, or wherever it comes from, do some data cleansing myself, I.B.M, IBM, combine all those to single values, upload it to HANA, combine it with trusted corporate information, and then start doing querying with an interface that is, it's not really for end users, but certainly it enables the power users that are otherwise going off doing their own thing. So that's a great technology from self-service BI to sort of self-service data marts and data warehousing. Of course, we're going to use the power of HANA to improve ease of use. So Explorer is an example of that. In the old days, we do a query, and then you'd send it off from Web Intelligence or another query product. You'd wait 5 minutes, then you get the results, and you use a local cache to interact with the information. Now, with something like Explorer, every time you click, it's doing a query. You don't really see it, though. It's just going off. It's doing a scan of the database. It's going through potentially billions of rows of records and coming up in near real time, giving you the next data set. So the power is not just about speed. It's also about making easier, more intuitive interfaces for end users. And again, that iterative feedback loop, it just leads to much better analytics over time. There's some examples of this at the experience.sap.com website for European soccer results, for example, dashboarding and exploration. I'm going to skip ahead a few because we're running after time. Mobility. It's truly ubiquitous. So you might have heard the statistics. There are indeed more mobile phones in the world than toothbrushes. It sounds a little incredible, but there is actually a blog post where somebody's gone through and worked it all out. And it basically turns out that there are alternatives to toothbrushes. If you want to clean your teeth, you can do it in a lot of countries with traditional methods. But you can't really replace a phone, right? And phones are about money, and you can use these phones in a lot of third world countries to access information that you can then use to improve the lives of your family. So mobility is becoming ubiquitous, and it's not just about the use of the mobile phone itself. It's also to do with the interfaces. Does everybody remember the movie Minority Report with Tom Cruise? Right? So we're all Tom Cruise now. If you have a tablet, you're manipulating, well, I'm Tom Cruise at least. We're manipulating information with our fingertips. So it makes it much easier. Analytics and these touch interfaces are designed to be together. Mobile devices are replacing desktop devices. They're not an add-on. They're not just for people on the street. They're actually just better devices for analyzing information in the first place. SAP is taking a mobile-first approach to this technology going forward. So make it easy for you to do analytics on your mobile devices. So here's a series of reports. These are Web Intelligence reports that can be exposed on the iPad. This is the new Exploration Views prototype. This is available now on the App Store, and I can just flick through dashboards of information. I can zoom in. Every time I click here, it's searching through potentially billions of rows of records on the back end. I can start using gestures to analyze my information, or to sort of flick through a chart to see more information. Of course, I'm an executive, so I'm not actually going to do anything myself. I'm just going to send this report off to somebody else to say, go fix this problem. So this kind of technology, it really is going to take off. You can download it yourself. If you look for the Experience SAP mobile application, you can start playing around with this with data from baseball, football, or very soon Formula One racing. An example of a company that's a mobile-first point of view is Allied Electronics. So they used our budgeting, planning, consolidation products. We were very happy with it. But they wanted to get it out to their executives. And it turns out their executives spend all of the time on the road. They're a holding company. They have 150 different divisions. And all of these people spend their time on the road. And they loved the iPad. They weren't interested in the desktop access at all. They just wanted the iPad version so that they could go and have discussions about the performance of each of their divisions, spending time on the road. And it wasn't just easier for the end users, they also found it was just the cheapest way to provide that infrastructure for those executives. So I think increasingly we'll see that it's a mobile first, actually replacing the old way of doing analytics. We can look forward to more types of technologies coming on. Voice recognition is starting to get serious. So we're talking about, being able to ask your computer a question and get an answer. It sounds like we're getting closer with these new devices. And I was just reading the magazine the other day, and they actually talked about brain waves. So soon we can just attach something to our head or our skin and start thinking our way through our data sets. It turns out this is actually real. You can actually buy these devices now as consumer products and attach it to whatever you like a crane, and start controlling things with your mind. I'm sure it won't be long before we'll be able to do this demo of Explorer just by thinking about it. And I'll skip a section here, but this decision making is not something you can do on its own. When I started in this industry, it was called decision support systems. So the idea was that we would help business people make the right decisions for their organization. But for the last 20 years, what we really did was help people gather information. And we left the decision-making up to them. But getting a single view of the facts is great, but it's not enough. Imagine if you took all of the Britain's and Ireland's politicians and put them all in one room and then bombed it. No. And then gave them facts about immigration and the economy. Would you seriously expect them to agree on anything? No, they have very different opinions of what that data meant and very different opinions of what you should be doing about that data. And that's the good thing. That's democracy. That's what we should be doing inside our organizations. So what we've introduced is products like SAP Streamwork that let you collaborate around information. And the brand new version of it lets you skip a few things. You can allow collaboration in applications. So if I have a customer issue, I can click a button and start collaborating around that problem. PowerPoint is not liking me today. The same with analytics. So in the new version, we have the ability to have analysis so you can follow streams. So you can find out who's been commenting on a particular report within the business objects environment, for example. So in applications and within analytics. So you'll see a lot more about this in the coming weeks. There's a brand new version of our BI On Demand platform that includes all of the discussion as part of the overall platform. Okay, so let me skip ahead a little bit to... There you go. So did you know, so analytics is great, but there's one thing I need to mention before we finish, is this. So did you know, for example, that children with night lights are far more likely to be short-sighted? It's absolutely true. It turns out that children, it's like 2.5 times more likely, if the child has had a night light up until the year 2, they're 2.5 times more likely to be short-sighted than if they haven't had a nightlight. So, this is a big deal. So this is reported. This is a study. Nightlight may lead to nearsightedness. So all these people were busy, turning off the nightlights for their children. But it turned out that that wasn't the problem at all. The real problem was that the parents of the children were short-sighted. And the parents wanted the night light so that when the baby woke up in the middle of the night, they wouldn't trip over the furniture and hurt themselves. And the children were more likely to be short-sighted because the parents were more likely to be short-sighted. So it was a good example of people looking at information and making bad decisions through false assumptions. And this is one of the areas where it turns out that a lot of research shows that we're not very good at analyzing numbers. If we really want to improve the analytics use inside our organizations, a lot of it is just improving the base level of culture around information, use of information, making sure that people make assumptions, that we question assumptions. If there's a big leap forward to be made, it's here. We actually think that, in most organizations, people are pretty good at analyzing numbers. It turns out our research shows that there are a few people who are very good at analyzing numbers. They do it for a living. And then pretty much everybody is pretty bad at it. So if you really wanted to make an improvement to the use of analytics in your organization, it wouldn't be about any of this technology we talked about today. It would actually be about teaching people to think better and changing the culture of the organization. So, with that, SAP. We have fantastic business analytics technology, lightning fast, easy, collaborative, aligned with your business that you can access on any mobile device. I honestly believe that business analytics is the #1 thing that anybody can do in any organization today to make a big difference. There's a big revolution in how we're doing this. The last 10 years we've been doing analytics, we now have to rethink we have to do that using the new technologies. On the back end, we can do things in a much simpler way against more real-time data. That means we have new opportunities to use data we haven't thought about before, and then we have an opportunity to get it out to lots of new people using these new devices. And you can start today. This technology is real. There's lots of customers you can talk to. You can go and see the boxes yourself in the stands out there. This is no longer science fiction. You can actually start making changes to the way you do analytics today. So with that, thank you very much for your time and the best of luck with your projects.